Chemistry videos, gas stoichiometry. Gas stoichiometry is just basic stoichiometry, but we add in the use of the ideal gas law. In regular stoichiometry, we use the expression grams to moles, moles to moles, moles to grams. However, in gas stoichiometry, we can add volume to the equation. So we can take and figure out what the volume is and turn it into moles, then use our balanced chemical equation and go moles to moles, and then we can either turn it back into volume or turn it into grams depending on what the question asks for. Gas stoichiometry is just basic stoichiometry, but we add in the use of the ideal gas law. In regular stoichiometry, we use the expression grams to moles, moles to moles, moles to grams. However, in gas stoichiometry, we can add volume to the equation. We can take volume, turn it into moles, then use our balanced chemical equation to go moles to moles, and then we can go back to volume or grams depending on what the question asks us. The rules are the same. First, we create a balanced chemical equation. Second, we take what we've been given in the problem and turn it into moles. If this is grams, we use the molar mass from the periodic table. However, if this is volume, we can use PV equals nRT to get what we have and get it into moles. Once we have it into moles, we move to number 3, and we use the mole ratio from the balanced chemical equation to determine the number of moles of the substance that the question asks us for. And finally, number 4, we can take the moles and turn it back into either grams or volume as the question asks. Here's a practice problem. In a reaction, 24.9 liters of nitrogen gas reacts with excess hydrogen gas to produce ammonia. How many liters of ammonia were produced? How many grams is this? The pressure in the lab is 97.8 kilopascals, and the temperature was 23.7 degrees Celsius. So step 1. Create a balanced chemical equation. So we have nitrogen gas, and we've got hydrogen gas, and we're going to create ammonia. Now we balance our chemical equation, and we start to solve our problem. Now we have in this problem 24.9 liters, and we have our pressure, and we have our degrees Celsius. But remember, degrees Celsius we need to add 273 because it needs to be in Kelvin. So if we add that to there, we get 296.7, which is our temperature in Kelvin. Okay? So now, let us use our next equation, which is PV equals nRT. And we need to turn our volume here of 24.9 liters of nitrogen gas and turn it into moles. So we'll go ahead and put our 97.8 kilopascals in pressure. We know that our volume is 24.9 liters. We have no idea what the moles are. We know also that the gas constant, R, for kilopascals is 8.31. So that's just a constant. We put that in there. And then we put our 296.7 Kelvin in there. And we do the math. Multiply both sides, divide, and we end up getting where N equals 0.9877 moles of nitrogen gas. So now that we have our moles of nitrogen gas, we'll go to the second step and turn it into moles of ammonia. Alright, if we remember on the last page, we had 0.9877 moles. So now we use our balanced chemical equation. So I got 0.9877 moles of my nitrogen gas, and if I multiply that by my balanced chemical equations mole ratio here, I will see that I should end up with 1.97, we'll round that to 5 moles of my ammonia. So I now know that that's how many moles. So if I was to take my 1.975 moles of ammonia, and then the second part of the question said how many grams was this? Well, if I multiply this by 17 grams in 1 mole, I see that I get, for my answer, 33.58 grams of ammonia. So there's one of my answers. And the next thing it asked me for was how much volume this was. So we'll go to the next page and solve for the volume. Now here we remember we have, from the last page, we ended up with 1.975 moles of ammonia, and we need to figure out what is the volume in liters for this. So we're going to use PV equals nRT again, except for this time we have to solve for volume. So once again we plug in our pressure, which in this case here in the lab said it was 97.8 kilopascals. We don't know what our volume is. We know that our moles here is 1.975 that we just calculated out. Our gas constant is still 8.31, being since we're in kilopascals in our volume here. And our temperature is not changed, so we're at 296.7 degrees Kelvin. Now we rearrange our equation here to solve for L, and we get that the amount of liters here, our volume, is 49.8 liters of ammonia. And we box our answer, and we figure out now that we've got both of them all solved. So as you can see, this is fairly straightforward. We took our volume and we turned it into moles. Then we used our balanced chemical equation and went moles to moles, just like regular stoichiometry. Then at the end we took those moles, and in one case up here we turned it back into volume by using PV equals nRT, and then we also took those moles and could turn them into mass and the amount of grams by using the molar mass from the periodic table. It's important that you review this over and over and over again till you get to feel comfortable working with these types of problems. And then, of course, as always, make sure you bring any questions into class and ask them. Gas stoichiometry is nothing more than basic stoichiometry. There's no limiting reactant to it. We're going to take volume of some type and we're going to turn it into the actual moles by using PV equals nRT, and then we use the mole ratio from a balanced chemical equation to turn it into the moles of whatever it's asking for, and then we can either turn those moles back into grams or back into moles using PV equals nRT again. Remember to keep trying. Chem is try, okay? Never, ever, ever give up, and stay gritty out there.